So when you think about differential equation, what is the first thing that come to mind? Like we remember from Calc 1, we took the derivatives of a lot of functions. So we had a function y equals f of x, and we took the derivative of that function using the rules of differentiation. Even the name differential equation sounds like it's something of a mystery, like it's some whole new concept. But we have really been working with differential equations since our days of Calc 1. Like take for example, if you was given a function, say y equals e to the 2x squared, and you was asked, okay, find the derivative or find y prime. Well, from what we learned in Calc 1, we know y prime is equal to 4x e to the 2x squared. And we also see that y prime is equivalently equal to y equal to 4x y, right? Because e to the 2x squared is the value of our function y. So that's pretty straightforward. We know how to do that. We use the chain rule. We realize that the function e to the x, the derivative of e to the x with respect to x, is simply just e to the x. So we have a composition of 2x squared, and we know whenever we have a composition, we must use the chain rule. Okay, enough with Calc 1. So let's say we fast forward a couple semesters, say 2 semesters or maybe 3. It was the first day of our differential equation class, and we see something like dy dx is equal to 4xy. It's been 3 semesters. We do not remember anything about y. We have no prior knowledge of y, and we are asked find y. In my opinion, I'd be like, well, that's just ridiculous because I have no idea what y could be. I don't know how to find this function. But this is pretty much a simple problem in differential equation. We must realize that we have a function and its derivative. So we have to understand the differential equation. The general definition of differential equation is that whenever there was one or more unknown functions and its derivative with respect to one or more independent variables, it is a differential equation. So this is a classic differential equation problem. As we're going to learn later on, there are a lot of different ways to solve differential equations, methods. And for this problem, the most obvious method to use is the method of separation. We have separable differentiation. Separable differentiation. Differential equation. So in using the separable method, you want to separate. It is exactly what it sounds like. You want to get the x's on one side, you want to get the y's on one side. Like, say, in this equation, what we might want to do first is multiply both sides of this equation by dx. That way we can have something like dy is equal to 4x y dx. And then we could try to divide both sides by y, where the y's cancels. And then we have something like 1 over y dy is equal to 4x dx. So this look familiar. This look like something. This look like it's a derivative. And this look like it's a derivative. It's a derivative of some function with respect to x and y. And we're being told these two are equal. So the first thing that comes to mind is that you might want to, so since we're looking for an unknown function, a plain function, the best thing we could do to get a function is that we must integrate. That is, we must take the antiderivative of the function. So looking at these two functions, first thing we might want to do is to take the antiderivative of 1 over y dy and the antiderivative of 4x dx. So it just tells us that, well, we know that 1 over y, the antiderivative of 1 over y is just the natural log of the absolute value of y. So it's the natural log is ln of y plus some arbitrary constant c is equal to, let's say 4x, the antiderivative of 4x is just 2x squared plus c2. This is c1 and this is c2. So here we could try to combine these constants, like by subtracting c1 from both sides, and this cancels out. But being that these are just arbitrary constants, we could just get a big representation of these constants, call it big C. So we could use ln of y is equal to 2x squared plus c. So looking at this problem, this is the same as saying the log base e of y is equal to 2x squared plus c. And this tells us that, well, y must be equal to e to 2x squared plus c. Well, this tells us that not only do we have a function, but we have a family of functions. And that is exactly true. Whenever you solve a differential equation problem, you do not get a single function. You get a family of functions. So the solution to a differential equation problem is a family of functions. And as you can see, we've been working with differential equations since calculus 1. But in order to find a unique function that we are looking for, we need an initial value. We need an initial value to get the unique function. So right now, that was like an intro example to what differential equation is really about. How do you go about solving differential equation? And as you're going to see, there are different methods and different representations of differential equation. This is just one of them. So now we're going to talk about some of the classification of differential equations. Classification of differential equations. So differential equations are classified into 3 main categories. So you can classify a differential equation by its type, by the order, or by its linearity. So the order or the linearity. So the type, there are actually 2 types of differential equations. You have the ordinary differential equation and the partial differential equations. So for ordinary differential equation, we have one independent variable. For partial differential equations, we have 2 or more independent variables. independent variables. And partial differential equations are not represented as dx, dy. They actually use the curly d. It's called a curly d. Say we had a function k, and let's say we had something like this. Tells us that this function is a multivariable function. Multivariable function. And this is the independent variable at this moment. The independent variable. For ordinary differential equation, we use dx. Say we use something like dy dx. Tells us this is a function of a single variable single independent variable, and this is the independent variable. This is the independent variable. So those are the two types of differential equations. The order of a differential equation is that of the derivatives, the highest derivative in our equation. Say we had an equation, say d2y dx squared plus dy dx equals 0. The order of this equation is 2, because the highest derivative in the equation is of order 2. The linearity of a differential equation is just, we consider a differential equation linear if, so for this problem, this is a linear because the power of that, of all the derivatives in the equation is 1. So we consider it a linear differential equation. So we can refer to this equation as a linear second order partial, not partial, I'm sorry. Linear second order ordinary differential equation. So for that example, is a linear second order ordinary differential equation. So if for some reason we have something like d2y dx squared plus dy dx minus y squared equals to 3, this is not linear because the function is not linear. So this is not linear. Not a linear differential equation. It's all about notations. But this is pretty much it for the introduction to differential equation. In the next couple of videos, we are going to talk about initial value problems. We're actually going to solve quite a lot of problems. We're going to talk about initial value problems, and we're going to talk about using differential equation to model certain real life systems. And we're going to talk more about differential equation. For now, hopefully you understood this video as much as I intended you to understand it. And hopefully I see you next time, or you see me next time. Thank you. Thank you for watching.